Good afternoon, Professor and classmates. I'm Architect Adolf Vincent Vigor, and I'll be presenting uh, my proposed application for linear programming. So this is a residential village design concept which I made 2 years ago for a certain company. So this is a land development project. So since it's post-pandemic residential project, it should have natural lighting, sanitation areas, cross ventilation, energy sufficiency, and edible landscapes. So I converted the problem into a word problem so that it would be easier to understand and organize the data as well. So the data is based on construction cost of the probable recreation facilities which is required to be built on the area. Okay, so a subdivision, once you build it, has a requirement for open space and amenities. So the problem here is what amenities should be constructed and prioritized given the limited land resources and of course the limited financial resources as well of the company. So in word problem format, so I will read this application. So, a land development company must decide which recreation facilities to build in its post-pandemic residential subdivision project as part of the regulatory requirements for the project. So, four new recreation facilities have been proposed, such as a swimming pool, a badminton court, a park, and a clubhouse. The company wants to construct facilities that will maximize the expected daily usage by the residents of the community subject to land and cost limitations. So the expected daily usage and cost and land requirements for each facilities are as follows. So you have the swimming pool that's with 75 people per day and a probable construction cost 4.5 million and a land requirement of around 150 square meters. Badminton court, so expected is 25 people per day, a probable construction cost of 1 million and a land requirement of 100 square meters. A park, expected daily usage is 300 people per day, probable construction cost around 5 million, land requirements are 750 square meters. Then you have a clubhouse. Expected usage is 180 people per day. A probable construction cost of 6 million. Then the land requirement of 350 square meters. So the community has a 15 million peso budget on a 2,500 square meter of land. So because the swimming pool and badminton court must be built on the same part of land parcel, only one of these two facilities could be constructed. So the firm wants to know which of the recreation facilities to construct to maximize the expected daily usage. So these are the decision variables. You have x1, x2, x3, and x4. X1 is the construction of the swimming pool, x2 is badminton court, x3 is the park, x4 is the construction of the clubhouse. So the formula is the maximization z is equal to 75x1 plus 25x2 plus 300x3 plus 180x4. So they are subject to the constraints. The cost constraint is 4.5 million x1 plus 1 million x2 plus 5 million x3 plus 6 million x4, which is less than or equal to 15 million. The land constraint is 150x1 plus 100x2 plus 750x3 plus 350x4 is less than or equal to 2,500 square meters, which is the land constraint. Then, since only either of the swimming pool badminton court could be constructed, then x1 plus x2 is less than or equal to 1. So, using Excel solver, so we got the following results. So the results state that since X1 is the swimming pool, we should prioritize the construction of the badminton court. I think which makes sense since it's more expensive to build a swimming pool than a badminton court. Okay. Then when you look at this, when you look at the sensitivity analysis, so when you click it, the sensitivity report and limits are not meaningful for problems with integer constraints. It's because in this problem, I added integer constraints, so it's either 0 or 1, so that we could choose if should we build the swimming pool or should we build the badminton court instead. So this is my application for linear programming. Thank you and have a nice day ahead. God bless.